Okay. Good evening, everyone, and welcome to what I believe will be a wonderful moment in AM industry. So I'm your host, Yihan from AM-E-DAO, and tonight we're live casting from China and hopefully bring to our audience and you guys a good dialogue between East and West in the 3D printing world. So welcome, you guys. So before we begin, I want to acknowledge that this stream is being simultaneously broadcast on AM-E-DAO's video platform and also the Going Globe Working Group of Additive Manufacturing Alliance of China video platform as well. So tonight we have over 200 industry professionals who have already pre-registered for this live event. So this tells us our industry is hungry for real and thoughtful dialogue about what we're going to talk about. We have three exceptional guests from Germany, each representing a crucial aspect of our industry's ecosystem. So let me briefly introduce our distinguished guests, and then I'll ask each of you guys to tell us a little bit more about yourself, okay? So we have Matthias Schmidt, managing partner at AM-Power, the company behind industry one of the most authoritative and trustful market data and reports. And also we have Arno, managing partner at AM Ventures. So managing millions of euros in the leading European 3D printing investment funds. And we have Felix Ewald, co-founder and CEO of DyeMansion, one of the global leaders in AM post-processing solutions. So Matthias, could you start by telling our audience about yourself and AM-Power's role in the industry?
Sure. Yeah, thanks for having me, first of all. My name is Matthias. I'm one of the three founding partners at AM-Power. Mm-hmm. We established the company 2017. Myself, I'm a mechanical engineer, had an education in Hamburg, did my diploma in Germany, mm-hmm. and started the company after my time at a research institute that was one of the very early research adopters of additive manufacturing and polymers and metal. Mm-hmm. And at AM-Power, I'm mostly responsible for strategy and go-to-market projects. So I'm mostly responsible when it comes to supporting companies in approaching new markets, assessing new markets for depending on different types of region, different types of technology or machine market entries. Yeah. And we're helping companies preparing those market access.
Nice. So thank you, Matthias, for coming to this event. And Arno, please introduce yourself and well-known AM Ventures.
Yeah, thank you very much also for this opportunity to be here also with the other guest. My own personal background is industrial laser technology. Okay. I started this 27 years ago with Trumpf, where I also spent some time in Shanghai, in China, living okay. here for 7 months actually, yeah. In 2006 and 2007. Mm-hmm. I'm an educated industrial engineer. Worked with EOS for 7 years in strategy and business development. And exactly 10 years ago, I co-founded AM Ventures with the goal of financing and supporting new technology companies to set foot in this industry and helping to bring innovation to the additive manufacturing industry. That was the goal 10 years ago. Today, it's still the same goal. Now with a big difference that we are not only funded by one family, which was our setup in the beginning. Mm-hmm. Since 4 years we, as you rightly said, are set up as a real proper venture capital fund, okay. with about 35 families invested into us mm-hmm. as people. We are a team of 8 people, and in the last years we have supported more than 20 companies. Nice. All around the world, from Austria to Australia, basically. So really pretty much everywhere, except for China yet. And today the portfolio is still 16 companies that we are managing.
Nice. Okay. Excellent. Felix, your turn. Tell us about your journey and DyeMansion.
Yeah, also from my side, thank you very much for being such a great host. I'm Felix. I co-founded DyeMansion 10 years ago. Actually, at the same time with AIM Ventures, there is a strong connection.
Yeah.
And we do industrial post-processing for powder bed plastics like SLS and MJF. And we have developed quite different machines. We call it our print-to-product platform. We covering 3 steps: depowdering, then surfacing, and then coloring. And we have 1,250 systems in field so far in more than 50 countries at more than 500 customers. So quite global approach, and we've raised around $50 million also from Arno. And it was quite a journey so far. We learned a lot. I think we will also cover some aspects during this session now. And my personal background is actually not that long. I studied business informatics, and I wanted to found my company from the very beginning. So immediately after my study, I co-founded DyeMansion. And that's it. Now we're here. Happy to be here.
Very interesting. So today we have expertise in consulting, investment perspective, and also entrepreneurial experience, all in one conversation. I think what makes this really exciting is I think we're bringing together different stage of AM value chain. So from Matthias' market intelligence to Arno's capital perspective, and also your practical implementation of different technologies and so forth. Before we dive into our main discussion, let's set the context about what we're going to explore. So over the past 2 weeks, we've collected questions from our community, engineers, entrepreneurs, investors, and industry leaders across China. So the themes that emerge tell us what exactly is on our industry leaders' head. So tonight we'll be tackling 5 areas that came up repeatedly. So first, the real impact of AI on additive manufacturing. Second, the honest state of global market dynamics and competition. And third, is what it actually takes to survive as an AM startup, okay? And fourth, we're going to talk about where money is flowing in our industry. And finally, the practical reality of East and West cooperation. So each of these topics connects to one another. So I expect we'll see some natural overlap in our conversation. So let's start with the questions. So about AI and AM. For Matthias, so currently people are talking about AI transforming manufacturing, right? In your market research, are you seeing the generative AI actually changing how people approaching 3D printing in many aspects?
Not yet. To be honest, it's hard to say where it's going to end. But what we do see is that everyone is exploring. I feel reminded of the early 3D printing phase where companies saw that as a very new technology and didn't really know what to do with it yet. So many companies, what they did is they bought a 3D printer and then they started working with it. And in some cases, they ended up with a good application and commercialized it. And I think it's somewhat similar in AI, maybe just in a different scale. So in AI, companies are exploring. I think everyone is trying out certain chatbots or picture tools, video tools. Some with relation to AM are trying more sophisticated things like quality assurance or reading data, designing for AM, optimizing designs, generating new ways of developing parameter sets for materials. So there's a very open world still and very, very, very unclear where the real value will be. I think we will definitely find ourselves in the next level of optimization of everything. So along the whole process chain, from identifying parts, designing and developing materials, up to parameters and quality assurance, everywhere I think we can increase the performance of the technology and decrease the amount of effort and investment that needs to go in, and the amount of hard work or manual labor that needs to go into each of those processes. But for me, it's still very unclear where will be the most important impact, because we see so many companies emerging right now or trying and working with the technology, and we don't know yet where it is reliable. Because especially when it comes to applications that are end-use parts, and many applications in AM are critical end-use parts that have something to do with medical, aerospace, or something where the quality of the part and the reliability are extremely important. There, I'm not sure yet where AI can play a definite role all the way up to the end, where you actually completely rely on the results and you trust the results. So the question is, up to what stage can you use AI, up to the point where it helps you optimize, and when does a human brain needs to jump in again because you simply may not trust the results yet. And it's a question of who signs off in the end of an AI-generated design, an AI-approved, quality-approved process. Who signs off on that this part is in the end carrying people in an airplane or is being implanted as a human bone replacement, right?
Yes.
So I think there's still a certain barrier that we still need to cross.
Okay, yeah. I mean, the AI people definitely want the input from our AM people, right? Like you said, whoever signs off will also contribute the data to the smarter AI. So Felix, AI question again. So has AI helped solve any of your surface improving or quality consistency challenges you see, or anything from post-processing technology advancement using AI?
I mean, I guess here I need to underline what Matthias just said. We are also in the exploration phase still. Obviously, I mean, we are probably with 10 years, we are not the youngest company anymore, but we obviously try to keep our entrepreneurial spirit, and we are very excited in our company. So we try out a lot of things, and we have some first applications where we believe we can create value for our customers. But we're still in the exploration phase. So some things will be about having more reliable machines. Some things is increasing the offers to customers through AI. But we are still also in the very early phase. But obviously, as an entrepreneur and CEO, I'm very excited about what's coming. And I mean, for me, I also have no clue where the real impact will be in the end, but I think there are two major things that I believe there will be a huge impact. The one thing is design. I think today, I mean, design, having freedom of design is one of the key USPs of 3D printing, but still today, I think it's also a key limitation, right? There are not too many people around the world that know how to design for additive. When you look at the universities, they started 2 or 3 years ago to really implement this. So I think it will take quite some time. Or AI will help them, right? Or I think AI will help a lot to come up with great designs for 3D printing. So at the moment, I think design is maybe also a limitation for growth in AI, the capability to do good designs. But I think AI will bring this to a key accelerator for 3D printing. And the other thing where I'm very optimistic is not necessarily directly related to 3D printing, but what we all are we are all looking for killer applications that change whole industries. And in many cases, obviously 3D printing is a key part of it, but it's not the only thing that you need to manage in order to come up with valuable applications. I have an eyewear frame, 3D printed glasses, and in the past, you needed a very expensive scanner. You needed to develop for many years a solution how you can bring the perfect fitted eyewear frame on your face. And I think through AI and I mean, in the meantime, with an iPhone, with the newest iPhone generation, you can scan your face just through the iPhone, right? You have all the technology in the phone, but still, you need to do a lot of software development, how to come up with everything until you have the perfect fit. And I guess the time in order to develop things like that will go down dramatically. The investment costs will go down dramatically. And what I want to say is that I think it will be way easier to create killer applications through AI, where 3D printing is one key part of it, but not the only part. And that's why I believe AI will accelerate also the development of new applications that have the potential to change whole industries. And regarding these 2 points, I'm very optimistic. The question is always, how fast will it come? I think there is no doubt that it will come. The question is just how fast, but I'm always on the optimistic side. So
Yeah,
I guess in the next few years we will see this.
Yeah. So maybe next time we do this, we'll talk about the killer application you talk about. Okay, sounds great. So Arno, AI questions again. So which AI applications in additive manufacturing you willing to bet your money on right now?
There are 1 or 2.
Okay.
They are not on the design side right now, because my underlying hypothesis for this is additive manufacturing has a big trust issue right now. Because additive manufacturing in many terms has failed to deliver on promises that have been made in the past, in terms of how quickly it will be implemented, how disruptive it is in terms of costs, but also in terms of how reliable it is on the large scale to produce high numbers of parts in exactly the same machine. And this is, in my opinion, the biggest challenge that we have right now, that we have to re-establish this trust in the technology by large volume manufacturers to say, yes, this technology is something that I can use in the future. And exactly on this point, I'm 100% convinced that AI can help us in the future to re-establish this trust, because we need gigantic amounts of data to prove that our machines can deliver quality, or to prove that the machines are wrong, but then to adjust them again to deliver the quality that is demanded by high volume manufacturing. So having said this, I'm convinced that the quality assurance side of additive manufacturing is where we will see the quickest success with the application of AI, whether it's in process monitoring, quality inspection, or also parameter development for new materials and for special applications. That's where I would bet my money on right now.
Great.
Yeah,
So
and maybe to add on this, I think I think Arno is right, and when you think about how much data is created during a printing process and how much data is also needed to do the process, and when you compare this to other manufacturing technologies, I guess there is a lot of potential for AI to have a positive impact on additive.
yeah, in my belief, I mean, AM is the most data-driven manufacturing method. So that has a natural connection between the two. So if Arno is betting money, Matthias, give AM people some advice on what their skill requirement would change if that day comes, the AI day comes.
The skill requirements for AM people
Yes.
to work in AM. Well, I think all of us, not only in AM, everyone needs to get familiar with those tools and needs to understand how they work, and also how to work with them in order to become more profitable. Because if you don't, then you're going to be replaced by someone who is more profitable. And I'm not necessarily saying that people or jobs are being replaced. I think more like people are getting more efficient and more productive using this technology. So someone who's designing for AM or who is responsible for quality in AM is going to be more productive. So he can take on more tasks. And I think people have to get familiar with that and how the tools actually work and how the framework works. Because you can, on the one hand, is you can always use a tool that a software supplier is providing you, but I still remember in my early engineering days, I had to learn how to manually solve FEM equations. It was a nightmare. It was like, it's something I never want to do again.
Yeah.
But actually, if I would be an engineer today and using an FEM simulation, I would know the background and how the tool actually works and how it's supposed to work.
Yeah.
So I know I can interpret the output that comes out of the system. And I think it's probably going to be the same with AI. If you don't understand the underlying mechanism of the tool itself, what was the training data that has been used, how is the training data being used, and where are certain links and intersections to other kind of tools, how your data connection works. If you just trust the tool blindly, I think that's something that's bound to fail. But if you really understand the underlying mechanism of how AI actually works, at least the basics of it, I think then you will be able to critically look at the tools also that are being provided by you. Because what's going to happen, I mean, what's already happening is that everyone is labeling every tool now with AI-powered, AI-driven, whatever, but probably not even half of them have any real AI, proprietary AI solution used, right? So
Yes.
I think you also need to become critical with what is being presented to you as a tool, and you need to understand, is that really something I can trust? Where are the links? Where is the data flowing into, etc., and how I interpret the results in the end.
Okay, nice. Yeah, that gives like AM people confidence. Like you said, I think people, if in order for people to be a judge, they have to have know-hows. They have to know how the in-depth knowledge of AM industry in order to justify if that tool is good or not. Okay, so I think all great insights about AI implementation. So early stage of AI integration. Definitely hopefully we'll be having some good applications in the future. Going to our next segment, right? So I've read your report, the AM-Power report. So I see some interesting patterns suggesting that AM industry is being more, I should say, selective or even mature in a technology adoption. So let's dig into that market reality stuff. So first question I want to ask Matthias again. So your report suggests that last year I think you see a 2.9% decline in metal AM.
Right.
And while the polymer AM grew 4.4%. So I wonder what's driving the divergence.
Well, maybe first of all, what's driving the general slowdown? Because I would argue there's a plus minus something right between them. I think the difference between those two is not as big or as important, because they're probably just going to catch up in the end. First of all, one important thing is the revenue declined, or the revenue stagnated, let's say, compared to the previous years. That doesn't mean that the units and the capacity of 3D printing declined. That actually increased. So what we saw is an average decline of machine pricing. So especially in polymer, we saw that. In polymer, we saw a segment of lower cost printers with a leap forward in quality enter the market, and that took market shares for much more expensive printers that customers are not necessarily buying anymore in some cases. So the unit numbers actually increased and grew over the years, but just not the revenues that had been generated by it. Generally, in polymer and metal, the difference is that if we talk to users of metal printers, they often have a pipeline of products that they can rely on. So they generally can very exactly tell you what kind of capacity they will need in the future, because they have qualified the technology for certain applications in medical, energy, aerospace, etc. And they have certain programs that will follow in the next 5 to 10 years, where they already can anticipate somehow what kind of capacity they will need. So you get very industry-driven, production-driven numbers from them, And that's also why the forecast in metal is quite positive still, remains quite positive despite the little dip we had recently. In polymer, it's a different story. In polymer, there are very few real serial applications. We have a lot of customization applications. Often polymer applications are also much smaller, driven by something like dental applications, hearing aids, iframe or eyewear frames. But overall, the majority of the polymer parts are still somewhat related to jigs, tools, fixtures, prototyping, consumer parts, where it's much more difficult to forecast the next year's development. Also, when we see the recent development in shoes, it's questionable if that's a sustainable business, because it largely depends on taste, on design aspects, on things that might change. It might be that some of those applications might vanish again from the landscape because some Adidas or Nike is just deciding at some point it's not interesting anymore to print the shoe. They just want to return to foam shoe inserts or something like that, right? So it's a bit less easy to predict that type of market in the polymer section.
Okay. Well, I like the idea because I see the similar things in China as well. Like you said, the polymer machines lower the price, and the boundary between industry and consumer level use is blurred.
Yeah.
So that kind of follows your conclusion as well. So let's address the elephant in the room. So we're talking. Okay, it's good. So about Chinese equipment manufacturers. Okay, we see many Chinese OEM, they're going global, right? So maybe for Matthias again, your actual data do you see the Chinese company going global expansion really affect the revenue or the competition from the Western industry?
Of course, yeah.
Okay.
I mean, if there's competition on the market, if a Western end user is being offered a machine that's maybe German made, European made, or US made versus a Chinese competitor, and both have the same level of quality, deliver the same level of quality of service, etc., but there's a price difference, then obviously the customer is inclined to choose the one with the lower investment. Now, the other side of the coin is that a lot of applications in 3D printing are quite sensitive, right? If you talk about medical, if you talk about energy, aerospace, defense, those are all very, very large sectors within additive manufacturing. Yes. And those sectors obviously have a higher hurdle to approach suppliers from outside of their home country, outside of their regional area. So that part is not being affected as much as maybe the consumer or the prosumer or the tools and fixtures market or other kind of areas. Having said that, I think it's also a very big opportunity for Western end users that there are now printers on the market with extremely high performance at very low cost, because it actually enables them to move into 3D printing and to enable new applications in the end. So for the industry, for the technology itself and for the technology adoption, I think it's a positive sign. When it comes to production level, I think we're going to ask different types of questions. There, the price per machine is not necessarily the most important factor. It's much more about reliability, it's about quality, it's about running a process that always delivers the same part quality. And then we suddenly see that some of the brands that we see in Germany are extremely positively seen by customers, by end users, and they're very reluctantly move away from those types of suppliers, even though there's a cost advantage or a slight performance advantage. In the end, when you create a product, it's mostly all about reliability.
Nice. Well, that's a great insight, because many Chinese OEM manufacturers, they probably don't have a clear strategy going to a different Western part, maybe US and European So thank you for clarify for two sections, maybe for the sensitive areas, and maybe try not so hard to push to get to compete, maybe for the industry, or I should say consumer level, or generic use of 3D printing. I think that would be also good for them to explore in the market. So to follow up that question, Arno, so from your investor network, what are the real concerns about Chinese companies versus the perceived concerns? Because Matthias talked about the good stuff about the Chinese companies, maybe high quality, maybe lower price, but what are some of the concerns that from investors or some of your portfolio companies' perspective?
I'd like to also start with the positive things, because there are now a lot of features in Chinese technology and Chinese company which Western companies admire, which is the speed at which requests from customers are being transferred into features in a machine, and the scale of how quickly Chinese companies can scale up and deliver products. This is very much admired by Western companies, because, as Matthias rightly said, Western companies are a little bit more rigid and cautious when it comes to quickly ramping up. And I think that brings up the concerns, because what Western companies are putting a lot of effort into is certifying their processes and making sure that they not only develop one machine that does the job once, they develop a whole product portfolio that delivers reliable, consistent quality over machine generations and different machine types. And they know that this work, it's almost invisible. It happens behind the scenes, because the machine doesn't necessarily change a lot on the outside, right? But in the inside, this is 80% of the work, although it's only 20% of the visible effect. And there, I think, in Western companies are certain concerns that some Chinese equipment manufacturers have, and not everyone. I really want to make this clear, because there are some very impressive demonstrations of scale at very high quality here in China. But what we also have seen here at the show now is that the fragmentation of machine technology industry in China is very high. So there are many very small players, right? And you don't know at which quality level of machines they have started to scale. And if you scale weak technology, that's really bad, because it comes back to this trust issue that the manufacturing industry has with additive manufacturing. If you scale unreliable technology, it affects all of us. It affects the entire industry's reputation. So that's one big issue. And I think a second point is also certainly data security, because there have been a demonstration of machines sending files somewhere. So innovations, designs that have been developed by Western companies suddenly popped up somewhere else without having pre-approved this. So there is certainly a concern that data might not be as protected as these companies would hope, and also maybe IP concerns are not taken as seriously as elsewhere in the world. So I think this is it comes back to this whole trust thing, that we have to be able to trust each other. Only then we can get this industry to grow.
Nice, very deep, and thank you for your candid response. I think that because some of them are stereotypes, and sometimes are I think more and more Chinese companies are trying to rebuild the image of Chinese made in China, right? I think innovation is one thing, and also to build trust, not only from the machine part, but also, like you said, the other factors that you guys concerned about. So thank you for your insight. So going back to Felix, I think you have a lot of different customers and from different countries. When European customers or your maybe American customers evaluate Chinese AM equipment, what are the actual decision factors? Like Matthias mentioned about price, and are there any other factors they think about Chinese machines?
Yeah, so first of all, I guess at the moment in the Western world, everyone is pretty much aware of the dynamics here in the Chinese market, especially. There is a lot of stuff going on, and I guess everyone is watching it as close as possible. I mean, we are very much on the industrial side, right? So with our customers, we work on industrial applications that scale to millions of parts. And I guess what maybe some people underestimate is we still have also a lot of stuff to do with our technology that we have in Europe and in the US. So in the end, obviously price is always important. Also, when you talk about scale, in the end, it's always about price. But with many applications that we are working on with our customers for many years, it's about how far can we push the quality and the consistency of the process. And I guess that's still where our main effort also as DyeMansion goes in. As Arno said, right, the one thing is to sell 5 machines, but the other thing is to have 10 machines in 10 factories around the world delivering the same output. And I guess that's still where we struggle in Europe or with our technology a lot. So, and I guess when we talk about Chinese companies entering this market, it's really also about pushing the quality. So in the end, price is always attractive and prices need to come down in order to scale additive. But with so many applications that we are involved in as DyeMansion, it's mainly about achieving a certain quality and then having a consistent process and a certain reproducibility throughout the process. This is where the main work in many applications goes in. And I guess if this is something that can be delivered by Chinese companies, it will be considered very seriously. And then obviously price becomes important. But I guess the first main hurdle is, and that we all have together as an industry, is still we are not yet at a point where we can say, oh, the technology is fine. Now it's just about bringing the costs down. It's still a lot about making the technology more reliable. And I mean, we saw it on the FDM side, right? What happens when someone comes that increases the quality and then still have a low and a very attractive price. I mean, this changed the whole FDM market. But still also there was the quality aspect. It wasn't just about, oh, this is a very affordable printer. It was, wow, there is a great increase in quality and a very attractive price. And that's why I think still quality and consistency and reproducibility matters a lot when it comes to our customers that look at technologies.
Nice, nice. So I think all of you guys mentioned a lot about scaled production, a large amount, large volume. So maybe for each of you, you can answer this. So which applications and which type of technologies that you guys are seeing in large volume production? Maybe starting from Matthias.
That's a difficult one. I mean, we can just probably come up with examples. Speaking about, let me speak about metal, because I think you have more insights into the polymer side. I mean, in metal, we one of the very early applications is definitely medical implants.
Okay.
There's a lot of medical companies out there who will tell you that they consider additive as the primary technology for every new product, which is also a major hurdle of implementation, because those products usually have a very long lifespan and you usually don't change manufacturing during that lifespan. You always produce it the same way for 10, 20 years of the product life. But if you bring a new product, then you can consider additive, and that is being considered more than 50% of the applications. Additive is being considered in all types of implant applications. So that's definitely one of those killer applications that has very, very continuous growth over a long period of time. I think it becomes much more complex if we look into aerospace or energy applications. You can probably summarize it there into everything that's complex, everything that's traditionally manufactured with extreme complexity. So where you have a lot of different manufacturing process steps, where you maybe join a lot of single parts into one parts. You have maybe complex welding assemblies. You have large forgings, large casting parts that have a high complexity. So it's I think more difficult to really point out a certain application there that's really driving the sector. I think it's just the general term of complexity and yeah, complexity and performance of parts that can be increased there. And on the metal side, I'll leave polymer to you.
Yeah, on the polymer side, as you also said in the beginning, there are maybe not that many applications, and it's also sometimes hard to foresee what will happen on the polymer side. I mean, we have some customers that have very company-specific applications where you can say, okay, this will change the whole market. It's a very customer-specific thing that we work on for a very long time with some customers. When you talk a bit broader about markets, I guess also the orthesis and prosthesis industry, so again the medical industry on the polymer side, is at a point where we know that many applications in the O&P sector will be where the main technology in the future will be 3D printing, and the adoption is happening now. It's not maybe in the future, it's happening now. So that's definitely on the industrial plastic powder bed side where we see the biggest traction. Then for 10 years I'm saying that 3D printed glasses will be everywhere. It's not happened yet. I mean, when you go to opticians in Germany or Switzerland or Austria, you will find in almost every optician a 3D printed eyewear frame. But there we are in a situation where no one really knows when it will happen that there is a broader adoption and how big the adoption will be. That's one of the things where no one knows exactly what will happen, but obviously there is big potential in many ways because the product in many ways is better than what's existing. So if you come to Formnext in November, I will try to I will bring a solution to scan your face, and then we maybe can get you 3D printed glasses to also push it a little bit more here. And yeah, overall on the polymer side, I was now with Arno and we just bought 3D printed shoes here at the exhibition today, and I'm also somehow still a strong believer that it will happen, but also there we see it for 10 years, that companies experiment with 3D printed shoes. And also there it's not clear when is there a tipping point where the whole industry will adopt, or how big will it be? Will it happen at all? So in plastics, we see it in O&P, definitely. We have some very company-specific applications, and there are many applications where there is a lot of potential, but very hard to predict when and if they will transform their specific industries or not.
Okay. Arno, you want to input?
Yeah,
thoughts?
I try to, so all the concrete and very valid applications were mentioned in my opinion. I want to be a little bit more abstract, because that's also how we work with our team of investment managers and technology scouts to help prioritize all the applications that are coming in. And on the polymer side, we always look at the kind of customization. I think customization is where additive manufacturing can play all the cards and where it has the biggest advantages. However, there are different degrees of customization. We spoke about it yesterday already. The simplest one is customizing taste, like fit to taste. That means flowers, colors, names on something, really nice and fancy and funny, but no one wants to pay for that. It's not an extra feature that's worth paying. The second degree is fit to a certain performance. That means I adapt my shoes to my bicycle or to any kind of sport. some passionate sports people might be paying for this, or some professional athletes might be paying a lot for this, but the average Joe, not so much, right? But where it becomes really interesting is when you adapt the geometry to the body, ergonomics, because you can reduce injuries or accelerate healing time with a customized implant, things like that. This is where customization becomes really valuable, because it can be measured in money and time. So super relevant for additive manufacturing, and there you can demonstrate a very clear business case, not only in the polymer side but also on the metal side. But when we are looking at prioritizing metal applications, almost every time we look at something, we realize that we're dealing with a surface to volume problem. It's always maximizing or optimizing the surface within a given volume. And that goes for filters, that goes for antennas, that goes for heat exchangers. We always want to optimize the mass, reduce the weight, minimize the volume of a part and the material consumption. So it's almost every time it's a surface to volume problem. So that's how we think, and then it becomes really easy to finding the relevant applications.
Nice. I like that idea. I think it's the first time I heard about the surface to volume. That's because people talk about lattices, right? Intricacies and structures, heat exchangers, but not one concept that kind of covers all that concepts. That's surface to volume. That's very very impressive from your research from your team. Nice. So let's transit to the third segment. Felix, you're an entrepreneur. You start your company, and I think we've heard about something online about your startup journey. You did something in your basement about experiments that you do. Then you become success in doing the post-processing technology as an AM startup. So let's talk about starting up a business in AM today. So questions for you. So I think DyeMansion really survived and thrived as well. So maybe some advice for entrepreneurs, not only for Chinese AM entrepreneurs, but also for the world entrepreneurs to learn from you. What are the most common fatal mistakes that you see in AM startups making?
I mean, maybe Arno has way more insights on the failing startups than I have.
Okay.
I mean, maybe I can turn it a little bit around. So what should you do to be successful? And I mean, you said survive, but also thrive, right? I mean, in the end, it's not only about surviving in best case, it's also about thriving.
For sure, yeah.
And I mean, look, we started the company because we thought there will be many applications that will go to tens of millions of parts, and we had many customers that told us that they want to do it, and we were very excited. And as a startup, you tend to do everything for free, right? I mean, we have a list of projects that failed in the end, but there are customer names on it at the biggest companies in the world. Yeah? They come to you, excite you, and as an entrepreneur, what you do is you work 24/7 to make it happen. And you really, I mean, the customers believe it, you believe it, everyone believes that it will happen. But many companies then sometimes also forget to charge money on the way to make it happen. And I guess that was one of our mistakes that we luckily survived, also because of investors. But probably we burned too much money on working on dreams that never happened, and just forgot to charge because we were so excited. And I mean, these companies are also very good in exciting you, right? As an entrepreneur, you are very easy to excite. So we worked a lot on projects that in the end failed, not because of us, or at least not only because of us, because of many things. But I advise entrepreneurs, charge money on the way to make it happen. That helps a lot. And if the customers are not willing to pay for your work, it's probably not worth doing it. So that's one of the things that I would do differently when we would do it again, and that I can give as an advice.
Okay, nice. Arno, you want to add something? Because you've seen probably a lot more companies than the Felix have built. So that's just one, right?
Yeah, we saw many succeed and many more fail. And I don't want to go into this, whole general statements about why what startups do wrong that you can read at every website and blog. I think very specifically about additive manufacturing, which is sometimes maybe counterintuitive, or at least not like the normal software world does it. But I think many companies scale way too early. Because especially in hardware, you need to have a stable and reliable system. And if you scale your system way too early, you are scaling something extremely unreliable. And the bigger it gets, the more scale it reaches, the more expensive it becomes to fight these defects that you have designed into your systems. And that killed so many companies. We have super prominent examples out there in the industry, especially even now in the US, still companies existing that are becoming larger and larger, and they are selling machines at negative gross margin. It's unbelievable that shareholders allow this, because every single machine that they are selling costs them a lot of money. So they've scaled a very immature system, and it's extremely dangerous and extremely expensive for the shareholders, for the founders, and for the entire industry, because again, the industry loses trust about these mistakes. So scaling technology too early and not considering unit economics from the very, very early days can be a very, very fatal, but certainly a very expensive mistake that many have made. And you can't say it often enough and focus often enough on this as a hardware investor, because it's a brutal mistake to make, and it will be harder and harder to remove it.
Yeah, just to follow up, I think that kind of matches the description of valley of death, right? Between the technical validation and then commercial production, right? But how do you validate though? Like before you scale it too early, like people definitely are very confident about their technology and machine. Like how do you validate? Do you ask more opinion from your customers, or do you have to go third-party authoritation to help you do that? How do you avoid that?
Asking opinions and getting any opinion that you want is very easy, right? It's about working extremely intensively with the first pilot customers and working extremely hard on getting a very firm commitment from them, ideally through a long-term partnership. And that means someone stress testing your equipment under real life conditions, because the conditions that you are creating in your own R&D is artificial conditions. It's like running a car on a treadmill and watching it. And of course nothing happens because it's not running outside of the road. But getting a first commitment from a very painful and annoying pilot customer that gives you extremely painful feedback. Felix knows what I'm talking about. This is what brings your company forward, and this is what generates the robust systems that can be scaled once they are developed. Well,
to Felix's point, do you charge them though? Like if it's really painful and it's really devoted, but do you charge them or say, oh, you are a partner, let's do this for free for a long time? Like how?
If the customer doesn't pay, it's no commitment.
Okay, interesting. Okay,
commitment.
That's a good answer.
If the customer is convinced of it,
yeah,
they will also pay for it. But if the customer doesn't want to pay for it, it's not worth anything.
Okay.
Yeah, but we had with our pilot systems, we offered them, because obviously there is a big risk for someone to spend money on a startup that has not delivered anything so far. Mm-hmm. We had in the contracts that they can give back the machines after 6 months if they are not happy, which so they paid. But obviously it was a risky move for us. If all of them would have given back the machines, I wouldn't be here today. but it also increased the pressure a lot. So again, we were then at the 24/7 thing. But it also helped, right? I mean, that helped a lot to build a product that then can scale, as Arno said.
And I think this is an important point because it shows how a good R&D or a cooperation contract is comprised of or is composed. And I remember this when I was working as an engineer with EOS. We cooperated with an R&D partner in the UK, and I negotiated the R&D contract with this other party there, and they said one sentence to me which stuck with me or sticks with me until today. They said, "It's only a partnership if you have each other by the balls." So everyone needs to survive this. Everyone needs to perform extremely well, the customer and the supplier side. Everyone needs to be under pressure to deliver well. Only then both are motivated to this partnership to succeed.
Nice. I think that's similar. We have a Chinese saying as well. I think 一根绳上的蚂蚱 means like, I think follows your description on that. I think many AM companies who's successful also have the similar experience of what you just described. So maybe another question for you, maybe a little bit about investment, also for startups, right? Because startup wants to have the funding, right? I think you've mentioned something about one company needed about 200 meetings to raise about $5 million. I found on the internet. Is that still the case in the AM landscape, or do we need more meetings, or is that still the case?
Yeah, in certain categories, maybe even more meetings are required, but not necessarily for the reason you think it is. It was also actually, for me, it was my own story when we raised the VC fund that we are managing right now. I think for the 35 investors that gave me 100 million in total, I pitched 300 times, and the first 180 times were rejections, simply because my story was not good yet. And so you need so many practice pitches to develop a compelling storyline, and that's not only a VC fund issue, that's a startup issue. Especially if you're an early stage startup, you need to practice and perfectionize your pitch. That means you need a lot of sacrificial pitches. That means companies where you say, all right, I can pitch to them, I can afford them to reject my case because I only see them as practice pitches because I really want to get perfect for the one that I'm really targeting. So nowadays, when we are sending our portfolio companies on the road to go out and raise another round of funding, our recommendation is always get at least 20 pitches in before you go to the real investors that you want to have. So it's also about practice. But yeah, in general, I mean, it's bloody hard to raise funds in additive manufacturing. It's even harder to raise funds in additive manufacturing as a hardware company. So yes, expect, if you're raising 5 to 10 million as a company that is not known, that has no traction yet, it's only a seed stage startup, yes, 200 pitches, very easy.
Okay. So Matthias, going back to you, I think you also look at some of the starting up company as well. So comparing to those successful, which you think successful or the struggling ones, what are the key differentiator between?
Yeah, I think much has been said and is all correct. And Arno mentioned there's a couple of general advice for startups that you can read up everywhere that account for everyone. But I think there's one thing I want to still mention, even though it accounts for also all other types of startups. It's the customer focus and the customer understanding. Because we've seen it so many times that, especially in 3D printing, in the early days in 3D printing, you were able to develop a 3D printing technology and sell it as a 3D printing technology. And driven through the hype, you automatically got customers, not necessarily the best customers, and they probably just bought one machine from you and you never heard from them again, or you scaled way too early, what happened to many of them. But it was very easy to find customers because it was 3D printing. It didn't really matter was it the right technology or not, because nobody knew anything. And that has completely changed. If you now want to bring a hardware company to the market, if you want to develop a 3D printing technology, it doesn't work anymore to just call it 3D printing and to say I can do everything with it. But you need to narrow it down really on the use cases and the applications and the industries and your customer type that you're targeting. And ideally, this is just one or two customers or one or two types of applications and customer groups that you're focusing on. As soon as you trying to bring a technology to the market with the promise it can do everything, it can print all types of polymers, it can print all types of metals in best quality, etc., all that doesn't work anymore. And there's unfortunately still quite a lot of startups that come from university or from the garage or from wherever that develop probably very great technologies, but they are so much in love with the technology itself, they completely lost focus of the customer and asking themselves, who can use that? It's the same with AI today. AI today, you can just develop any AI tool. It doesn't really matter. Everyone is giving you money because it's AI. But it will be the same in a couple of years where people are asking, okay, who is using that actually? Who gains value from your application and who's ready to pay for that in the end, right? And that's where we are with 3D printing now. If you want to bring anything, actually, hardware, software, materials, if you want to bring anything new into the 3D printing market with a USP in AM, not just copying an existing one, but bringing some new tech into this industry, you better know exactly your customer and you better bring along customers already that where you are convinced that their application is going to be better, or it enables them to bring up different types of applications, better applications. Your customer in the end needs to make money with your technology. That needs to be your mindset. So he needs to either increase his revenues or increase his margin or increase his winnings. That's what drives his investment decision into new types of tech. Nice. And I think this is the mindset that you need to develop if you want to bring any new tech into 3D printing today.
Yes, nice. Thank you for all the advice to entrepreneurs. And to follow up on that, so to transit to our next section is about investment, right? I think you touched on about the entrepreneurial side, but many of our readers are also investors from China. So next section, we want to talk a little bit more about the investment. So we have 30 minutes left. It's a wonderful conversation. So I'll try to make questions directly. So for Arno, right? So I think you've mentioned something about late stage and funding, dropped from 100 rounds to in 2021 to almost 17 in 2023. Is it a temporary correction or is it fundamental shift? I think you've touched on something about that, but just give me a little bit more conclusive opinion about that.
I think to a certain extent it was a temporary shift for a very simple reason. Those early stage rounds that were raised 2022 and earlier were raised on incredibly high valuations.
Interesting.
And after 2022, once we got deeper into this crisis and the disillusionment that happened around AM technology, valuations dropped and multiples dropped that you would be able to raise on your revenues, right? So later stage companies, of course, they are not raising money on a promise, but on multiple times revenue that they are generating. So now imagine you're an early stage startup that raised them seed round on 20, 30, 40, $50 million valuation, promising 4-year revenues of 40 million and expecting 5x or 8x or 10x on this revenue. So they promised their investors basically, give me 10 million now, you get 20% of the company. I'm going to turn it into 40 million revenue, and you will get a 400 million valuation once we raise our Series A or Series B in 3 years from now. So now, in the meantime, two things happened. One was the revenues didn't happen, or at least not to the extent that was promised, if even. They managed to generate a top line of maybe double-digit $1 million. Maybe. And that was already painful, because 8x on 10 million is much less than 8x on 40 million. But the big problem was that generally additive manufacturing revenue multiples dropped to 1. So you couldn't only raise not 400 million, but suddenly 1 times revenue, which was 10 million, because revenue was also underachieved. And that led to a very significant problem for the founders and their existing seed investors, because seed investors paid a too high valuation in the seed round, and the founders couldn't achieve the performance that was expected. So they couldn't achieve the targeted valuation, which made them delay the funding round and loaded themselves up with convertible loans to somehow try to weather the storm and wait for better times when hopefully the market multiples and revenues would have recovered. So far, it has hardly happened. So we are now in a situation where the late stage funding rounds are slowly coming back because revenues are slowly recovering, and because the founders accepted that they cannot achieve the valuations anymore that they promised their original investors. But it leads to a very difficult situation. We have very exhausted founders out there right now because they've tried to raise money for 3-4 years with only overseeable success. And the discussions with their existing shareholders were also not the most pleasant ones because these guys had other expectations.
Interesting. Because my follow-up question will be the valuation, but you already mentioned. Thank you for sharing that. Because I wasn't sure if that's the proper answer to ask for investor like you. Thank you for sharing that. So about Chinese company, what do you think the success rate would be for a Chinese company to maybe seeking European investment? Is that feasible? Or if it is feasible, how would they improve their odds?
I must say I have seen only very, very few. Okay. And I'm talking probably less than 5 funding rounds in Asia, or especially in China, with Western participation. Actually, off the top of my head, I'm not exactly sure if I can even recall one. But being an early stage investor myself, I can give you a simple explanation for it. It's actually what Felix said earlier. As an early stage investor, I cannot rely on the financial plan that the founder gave me, because they don't know if they will achieve it. I have to be able to read the founder. I have to be able to assess if the founder is a good entrepreneur before they know it themselves, before they have found it out themselves. So I think what the one skill that I have to be extremely good at is understanding people and understanding their potential. So I have to work very closely with people, and I have to trust them in the first 1 or 2 meetings. I have to understand if I can trust these people and if I know that they can do what they promise me. And of course, for me, it's so much easier to read people in my culture that is native to me. That this is where I was born and bred. This is where I can read people. But if in China, it's simply impossible. I've spent a little bit of time in China. It was enough to learn 7 words that I can speak in Mandarin. So no, I don't have the cultural competence to read people at such an early stage. I might be able to read a financial plan for a later stage company, because then it's about numbers, and then it becomes mathematics, which is a lot easier to understand because we engineers, we speak mathematics. But early stage investing is a people business, and that is a different language.
Okay. Well, thank you for sharing that. I hope you could come to China more and more times and to learn more Chinese good entrepreneurs and help them to build success internationally.
I'd love to.
Okay. Just to follow up on that, so in the future, right, maybe in 2 years, 2025, maybe to 2027, where should I should say smart money should be flowing into around AM industry?
Nowhere else than where it should flow into today already. It's the applications and the building trust and confidence in the technology that we still need, right? Our industry's problem is not where do we get the next 3D printer from. We don't need more printers. We need less printers. Because this whole industry is full of confused customers that don't know which company, which technology to buy and which brand to buy, because there's too many of them. The variety of technologies is a big issue. So I think we need consolidation. We need a significantly reduced number of machine principals and machine vendors. And this will, in my opinion, lead to very profitable companies that can finally focus on what the industry needs, which is developing applications and working on the resilience and the reliability of the machines, right? To build machines that simply deliver quality at whatever day, at whatever geography, and at whatever material and environmental conditions that I'm having. And then we can develop those applications that deliver real value. And I'm not talking about toys. Toys are nice. It's so funny to have them on your shelf and look at them and then throw them away after 3 months, but they are useless. They are not delivering value. They are not making the planet more peaceful. They are not making the planet more sustainable. They are not saving materials or energy or money. But this is what heat exchangers in electric motors and lithium harvesting filters and spaceships do. This is where the real value is. So this is what needs the smart money.
Nice. So Matthias, because I think you have a lot of market intelligence as well. So which segment or which kind of printers, like Arno has said, are underinvested, or which areas are overinvested in your market intelligence?
Well, let me turn to the positive ways. I think the ones that I would like to see succeed more and I think that would add value are probably the ones that are specifically designed for certain applications, at least for the ones that have a significant volume. We see some of those coming up. There are printers that are just focusing on shoe insoles, orthopedic or whatever types of shoe insoles. So they're just doing that. They're completely focused. They do nothing else. They do that perfectly because they come with the right software environment, with the right pre- and post-processing material, etc. So if you find a certain application that adds value, and that brings me back to what I've said before, designing an ecosystem around that application and delivering the perfect solution for that type of application that none of those customers can get around. I think this is something that many are still too cautious to invest into, and but I think there is real value in it because we see it in other industries in the same way, that you design dedicated machines for a specific application. I know it also kind of contradicts the basic idea of 3D printing, that you can just use anything with it, but we have enough, like Arno said, we have enough of those. We can print all kinds of metal by now with the variety. We can also print all kinds of polymers by now, to different quality, different costs, etc. But the technology landscape is so vast, it's so overly crowded, and it's so hard to sell anything in 3D printing right now because you're competing with many other players. But if you actually don't compete with 3D printing, but if you offer your customer a new way of producing a certain type of product with your solution, I think it tells a different story. I think there's value in that, and I would guess that this is something where some of the investment money will flow more into in the next couple of years.
Nice. Since we don't have too much time, I'll try to go a little bit faster. So our final session about East and Western cooperation, because I'm currently forming a Going Global a working group, hopefully to help to bridge Western and Eastern companies in the AM field to help them find more success and maybe explore some overlapping or distinguished applications in each region so that they can help each other. So I'm really trying to find value about global applications and cooperations. So questions maybe for Arno again. So there's also often a perception gap, right, between what Chinese companies think Western customers want versus the reality. So what's the truth?
Very easy question.
Yeah, if you want to add something,
No,
go for it.
It goes a little bit in the direction of what I think would be a recommendation for Chinese companies in
please.
Germany to become successful, right? And I think China has showed it ourselves what it needs to do, because in the 90s China has started this themselves for Western companies coming into China, because it was mandatory for Western companies to have a joint venture partner here in China, right? They couldn't do it alone. And this way they became pretty successful because they had this cultural translator, right? It had a lot to do with like business diplomacy, more or less. Because the Western companies would have never become successful here by doing it themselves. And I think it goes exactly the same direction in the Western direction. So a Chinese company trying to conduct business on their own in Europe is going to fail, because the big questions that I can only speak for the Germans, but I would assume it's valid for other European countries as well. So there's this Chinese company which is on the first look delivering pretty solid technology, but what happens after I buy it? Where do I get the support, right? Who's there? Who can I call? How can I discuss my issues with them? And do I still get service and materials and spare parts in 3, 4, 5, and 7 years? And for, let's say, a newcomer to Europe, this is super difficult to prove. But it could be extremely easy if you partner with someone who has this reputation already, who speaks the Western culture, more or less, right? So I think just like the Western companies, Western companies partnering with Chinese JV partners to become successful in China, now you guys are the one who are spreading your technology and your products globally. I think that's probably what I would recommend. Go and find the local JV partners. Partner up with someone that has a reputation, that knows the market, and become or get these cultural agents that can help you to build the reputation.
Yeah, just to clarify, because I think many Chinese OEM makers, I think the partners you mentioned in their perception is to find distributors. That's what they normally do. Are you suggesting the partnership in a deeper level?
Yes.
Okay.
Yes,
You mean
because
the stock share?
It goes a little bit in what I said earlier about the Chinese strength in delivering speed and innovation and at scale, but still, let's say, with some potential on the validation certification side and delivering stable quality over a long time. I think this is something where I think there are companies who know exactly about these requirements in the European manufacturing industry, because they've been supplying their technology from wherever to these users of technology for decades.
Okay.
That infrastructure has been built from the 1950s and even earlier to a certain extent. So there are companies who know about these requirements, and it's really about R&D cooperation. It doesn't start when you are selling a readily developed product. It starts already in the R&D phase.
Okay. Maybe Matthias, you can add something onto it. I mean, does it have to be? So what if the Chinese company really wants to do that, to have a deep connection, maybe co-found a new company? Is that feasible? Or if that's the case, and how you guys can advise them, like what do they really need to address before they think about that?
Well, I don't want to dive into any technical aspects, but what Arno said is exactly right. I mean, it's about most of the additive products that are being produced, most of the additive customers in Europe and the US are having very dedicated products, and they are looking often for a partner rather than a supplier, right? So they need someone who supports them at the beginning of the journey of maybe developing the product. Maybe they already have a ready product, ready to print product, but they need always ongoing support before they buy a machine and after they buy a machine, until they buy the second and third and fourth machine to actually scale to production. So they need someone who is able to travel to them easily, to speak his language, and is there to help and support. And it's much more about a partnership, because we still don't have that situation that customers come with a ready to manufacture product to the OEM and say, here, this is my product, I want an offer, this is my requirement. There are some cases where it is at this stage for some products. Talking about something like medical products, they are already so advanced that they have a very specific spec sheet where they approach suppliers and it just make me a quotation and we make a legally binding contract. There's not much of a partnership. But I think the majority of customers in AM still rather look for a partnership. Now even more than before, because with some of the bankruptcies going on in the additive world, in the Western additive world, people are even more selective now with their partners because they cannot be sure if they're going to be around for the next couple of years. So they need someone with even probably a history involved. So someone they probably already know. So you might even want to consider and screen the supply chain of the customer already, which kind of companies are delivering into this type of industry, so they already have a brand name that you can attach on. Because otherwise it's really about who do you trust, how long will they be around, will they support me all the way through with my product, and can I scale with them in the end?
Yeah, maybe for all of you, like what kind of model that you guys think is feasible? Like how deep the partnership can go? Like, does that stay with the, just R&D, maybe exchange some, technical co-development, or maybe we're talking about co-founding a part, like a new company, or what would be the best model for Chinese company to team up with European local partners? That may be a tough question. Just give me some ideas.
We are spending the week here now, also to find out what is a good way, what could be a better way.
Okay.
And I think we should do it on all levels, right? I mean, we also met now other investors. We are visiting printer companies here. We are visiting users of the technology. It's not an easy answer, and probably we need to spend some more time what a very good way could be. I think for me, on a very high level, I mean, obviously, there is the Eastern and the Western world and additive are not very well connected. On a very high level, I mean, I just did a PowerPoint slide where I had the 12 trillion manufacturing market, global manufacturing market, and then I put the additive market inside, and it was hard to draw such a small circle. And when I look at that, I think, I mean, we are so much on the same page, right? I mean, we are such a small industry. I guess it's not about Eastern and Western world. It's really about pushing this together. And sometimes I have the feeling we also need a little bit more of an open mind altogether. That's why I think these exchanges are very important. Yeah. And what the best way will be or might be is something that we may figure out in the near future. But I guess spending more time in the other regions is certainly helping a lot.
That for sure. And maybe to build up on this, I think the best approach to this is not having a standard approach, because if you and I probably this would count exactly the same for a German company going here. If you're a Chinese company going over to Germany, building a collaboration with someone is a super individual projects, right? There are public companies, there are family-owned companies, there are companies with simply many shareholders or owned by private equity, and they all have their own individual approach to building corporations with other companies. Some like joint ventures, some want to be acquired, some just want a contractual relationship but no equity relationship. And I think it could be counterproductive to come with a standard approach to Germany and then expect others to follow it. It's rather just be open, and as Felix rightly said, start a discussion, spend some time there, meet these people and talk to each other, because in the end it's always about building relationships where you can call each other on the phone without having to pre-align a meeting, right? This is when you know you have a friend, right? When I can call my friend at 10 o'clock in the evening and still talk about some stuff that is relevant for both of our business, then I know I have a trustful relationship, and that's the best basis to start on.
Nice. Matthias, do you have some idea about what model would be?
No, same here.
Okay.
It's a people's business, and it's a trust-based business. So it's a lot about. It also probably depends if you are polymer, if you're on polymers, if you're in metals, if you're focusing on a certain industry segment, etc.
Yes.
So it's really an individual decision. Also depends if you just look at the German market or the European. If you look into dental, like there are so many variants. I think I would consider before thinking of how my customer thinks.
Okay.
Where is my customer? Where can I reach him? What does he prioritize? And I think that dictates kind of a lot of the aspects.
Yes. Just nicely put. So let's transit to before we open up to audience questions. I think we built up many. I want to do a quick round on some broader strategic questions. I hope all of you can answer. Short answer, please. So first would be I think Felix touched on that. Will additive manufacturing reshape manufacturing, or remain just complementary to traditional methods? Give me some short answers.
I can answer.
Arno, please.
No.
No?
No.
Okay.
Additive manufacturing is not here to replace conventional manufacturing technologies. It will be another way to produce things, to produce new things. But if something is designed for a conventional manufacturing process, it should not be replaced by additive. It's a new way to produce things, but it will not replace conventional manufacturing.
Okay, cool. Another quick question. If anybody agree or disagree, please just join in. Who will dominate the AM value chain? Equipment, material service, or maybe outsiders? Somebody not from our industry.
Right now it's OEM, I think, machine. Currently, at least.
Okay.
But they're also not in the very best shape. I guess in the end,
They're not in the best shape, but they're dictating how the technology works, and they are the first. I mean, I'm wondering who's being first approached by user, by customer, and their
Yeah.
first address is always when someone wants to move into additive as a product, he's first going to the machine OEM, even
But
if he ends up as a service supplier. Probably.
It's true today. I agree with you today, but I don't think this is the model of the future. Look at how the automotive industry works, right? If BMW designs some new feature in their dashboard, they go to Henkel or to Evonik or BASF and tell them what they want, and then they jointly look for a hardware vendor to give them a machine that can process the material for the specific application. And
Yeah.
I think when we look at the additive manufacturing industry right now, especially on the hardware level, how fragmented it is with a plethora of so many hardware vendors out there, they will be commoditized in a not too distant future.
Interesting.
But in the end, in my opinion, I think everything needs to evolve at the same time. I think all parts of additive have to grow and develop, and then in the end we will see what's happening. And in the best case, there is not one dominating force, right? I guess the best for the industry would be if we see growth in all segments, and not having this one dominating factor. I guess that would help a lot.
Okay. The next one. In 5 years, what's more important? Is it technical advancement? Is it business model innovation? Is it AI adoption? Just give me some quick, short phrases that you think was the most important in 5 years in our industry.
I think it's business and strategy. I think right now we're at this turning point where the right strategy wins. I think it used to be the technology that wins,
Yeah.
probably, if we look back. I think what decides today who's going to survive in 5 years is what strategic decisions they make today. How to shape, because everyone needs to reshape, and everyone is reshaping their strategy in AM right now. Everyone.
I agree,
Materials, OEM, software.
Yeah.
And who's making now the right decisions, I think is the ones who end up.
Yes, I agree. I see some people some companies who have better technologies but not doing as good.
Yeah.
Using different wrong strategy. So maybe the last interesting one. I wish all of you could answer. If you could change one thing about how the current AM industry operates, what would it be?
Reduce complexity, I would say.
It's really hard to make this statement without insulting someone.
Well, use some generic terms. Use some abstract concept, or don't have to be specific.
What I would change right now is I think there are too many companies out there, big companies, that have broad portfolios of self-cannibalizing technologies. I think the winners in the future are the ones that are unlocking one or two specific applications and are going for it and develop a very, very deep understanding of this niche. That's why I'm even questioning if there even is such a thing as an AM industry. Because what are the synergies between polymers and metals? Virtually none. So I'm waiting for those companies that become $100 million, $200 million companies on one single application, owning the whole chain, fully integrated. And I think that is not even 5 years away, because we see already a couple of them scaling very impressively, and they will show that it does not really make sense to have an armada of salespeople out there that are selling 7 different technologies in the range of 20,000 euros to 2 million euros. It's such a waste of time. It's such a waste of resources.
Okay, find niche and dominate it.
Yeah.
Do you guys want to have more different ideas?
More collaboration than fighting each other.
Say that again, please.
More collaboration instead of fighting each other.
Oh.
We are just a too small industry to think how we can compete against the other one company.
Yeah, interesting. I see in some technical, like for different types of technology, I think it's different dynamics.
And it then would lead to application focus, I guess, if
Okay.
we would look more outside.
Okay. Matthias?
Yeah. It goes into the same direction like Arno said. It's about, I think, reducing the complexity and stop trying to 3D print. Like, put a big question mark on 3D print, think applications, and reduce this big complexity of trying to solve a lot of problems at the same time.
Okay. So yeah, I think it's already over the time limit, but I'll try to take a few questions from the audience. 大家这个直播有没有这个问题？因为我现在才看手机，才能看到这个大家之前的这个问题。我看看有没有人提问哈。Yeah, somebody said AI is good to break the boundaries between you know, the technical know-how between the different players and users. So that's one opinion. And also something about future. Oh, a question about Starship Raptor 3 engine. I think that's if you guys feel it's too sensitive to answer, just try to give some generic answers, and that's fine. What's the advantage using AI in aerospace? I think we know the answer about this, but just give me some ideas about Starship Raptor 3. Elon Musk.
Raptor 3 engine. If you look at the design iterations from Raptor 1 to Raptor 3 right now, Raptor 1 had some AM parts, but also external components, and the designs looked a little bit like someone was mimicking let's say a conventionally made engine and 3D printed. And then Raptor 3 is simply fully integrated. It's a piece of art.
Yeah.
It's and this, now think about a couple of generations onwards with more AI helping to optimize the designs. Additive manufacturing has, there's 100% convinced if we are going to Mars, this was enabled by additive manufacturing. 100% sure. This would never have been possible without our technology.
Nice. Well, that gives huge confidence, I think, to all of us, right? I think another question. What's the future applications are you guys envisioning? Maybe some already you know, but you don't want to talk about it. That's fine. But just give me some ideas about futuristic applications of AM adoption. And I'll take one more question before we wrap up.
I think what I find interesting, and recalling again some of the talks I have with report users, so companies who provide information for our market report and their forecasting, etc. And especially when you talk to energy and aerospace users, it's, I think, the most interesting conversations because of, like I mentioned before, the roadmap. So it's not necessarily a future applications, it's about what they have in their drawer. So they have so many applications now. Once they broke through the barrier of qualification, what they did the past 10 years was just making sure the process works. And what they now pull up is one application after another. And you do the one application, the fuel nozzle, you do that for one engine. But this type of company has many, many other engines in their portfolio. And they all come to an end at some point in their lifetime. And suddenly you have fuel nozzles everywhere. And this is the way a fuel nozzle is being designed. So this is just a generic example, but there are so many others like heat exchangers, like every type of hydraulic applications, etc. And it's just the scale effect that gives me is so interesting, because you suddenly realize probably at some point, and even if we see the large printers, if you look at an aircraft engine, at some point maybe 50% of this engine is printed, not the whole thing.
Mm-hmm.
But imagine this huge piece of high-end engineering being mostly 3D printed is, I think, an extremely compelling business case for this industry that's driving us.
Okay, great. I think one last question about consumer electronics. That's one of the hottest topic in China. But I know the European doesn't have many Apple or suppliers. But I want to know your thoughts about consumer electronics, because I think iPhone, many news around iPhone making about the also about the watches. That's where our AM circle would think that's where the future of volume production would be at. So last question about that area. Do you guys have some opinions or ideas about that region of application?
I want to be a little bit careful because some of my portfolio companies are involved in projects on various aspects of consumer electronics printing, and we're not necessarily talking about the frames or the housings only of consumer electronics. There's also ways how to save weight and volume inside these parts by printing certain it gets difficult to really stay discrete, but to print certain components onto other components.
Okay.
So that whole integration, it's also happening inside these tiny devices to a very impressive extent.
Okay. Well,
so
thank you.
I'm very optimistic when it comes to electronics, consumer electronics in general.
Okay. Matthias, do you have something to add?
Well, it's for me always amazing when I come to China to see the depth of supply chain is established here, and the AM applications. If I visit companies here, there's so many applications regarding electronic devices. So it's eye opening because we, like you said, we don't have much of a supply chain in Europe in that regard. But I'm pretty convinced that AM will play a major role in metal, especially metal components. It took some time to qualify. The requirements are just insanely high in this type of industry. But also the benefits are extremely high. So I'm convinced we will see more of that. Also because, and that's another aspect, talking of Raptor or those types of engines, it's also just the speed you can achieve, right? Every other technology, every tool-bound technology, forging, metal injection molding, you always talk about weeks, months, sometimes years of advancement planning, and AM just enables you to just change the design, iterate design so extremely fast. And I think that also counts for this type of technology, where you have where the design cycles are getting shorter and shorter. So there is, I think, a massive added value, and it's just this high quality barrier that you need to reach in terms of surface, in terms of density, polished parts, etc. It's just extremely difficult, but we seem to get there.
Yes, thank you. Okay, yeah, we're 11 minutes over. So thank you to our incredible guests. Again, Matthias from AM Power, and Arno from AM Ventures, and Felix from DyeMansion. And I think today, our audience, we have more than 10K. So more than 10.5K people have joined us live tonight. This conversation will be available as a replay, and but I hope it's sparkled ideas and connections that will continue beyond tonight and also across the border between countries and continents. So thanks to my team and who has supported our live tonight. And this has been AM-E-DAO's first international live conversation. And based on tonight's exchange and engagement, I believe it won't be our last.